Welcome back to Mr. Scott Maths. In this video we're going to take a look at how to factorise quadratic expressions where our coefficient of x squared is greater than 1. So if we want to factorise this expression, 2x squared plus 15x plus 28, what we first need to do is multiply together our coefficient of x squared by our number term on the end. So 2 times 28, that gives us 56. What we then need to do is find a pair of numbers that multiply together to make 56, but also add together to make 15, our coefficient of x. So let's first think of some factors of 56, and we're going to write those factors out in their pairs. So we could have 1 and 56, we could have 2 and 28, we could have 4 and 14, or we could have 7 and 8. So we need to think about which of these pairs of factors also add to make 15. Now that pair is going to be 7 and 8. So these are the two factors we're going to use. So we're going to put these numbers in here. I'm going to write this as 8 times 7 equals 56, and 8 add 7 equals 15. I'm then going to rewrite this original expression using 8 and 7 as my coefficients of x. We'll see how they add together to make 15x. So I'm going to rewrite it as this. 2x squared plus 8x plus 7x plus 28. And we see that these two x terms here, they would add together to make the 15x we started with. Now I'm going to factorise my first two terms and then factorise my third and fourth term. I'm going to do those separately. So factorising 2x squared plus 8x, I see that I can take a 2 out of both, and I can also take an x out of both. So that's going to be 2x outside of my bracket, and then to go from 2x to 2x squared, I multiply by x. To go from 2x to 8x, I multiply by 4. So that becomes 2x, x plus 4. To factorise 7x plus 28, I can take a 7 out of both those two terms. To go from 7 to 7x, I multiply by x. To go from 7 to 28, I multiply by 4. So my new expression is 2x, x plus 4, plus 7, x plus 4. And what we should notice here is that these two both have that x plus 4 in them. They both have that matching x plus 4 there. So we can factorise this whole expression, taking out this x plus 4. And we can see that they're multiplied by 2x and 7. So I can write this as my double brackets, 2x plus 7, x plus 4. So there's my double brackets, 2x plus 7, x plus 4. And this expression is factorised. The next expression we're going to factorise is 3x squared plus 20x plus 12. So again, we need to start off by multiplying our coefficient of x squared by this number term on the end. 3 times 12 gives us 36. We then need to find a pair of numbers that multiply together to make this 36 and add together to make our coefficient of x, which is 20. So we can write down our factors of 36, thinking about our factor pairs. Our first pair would be 1 and 36, or we could have 2 and 18, we could have 3 and 12, we could have 4 and 9, or we could have 6 and 6. So which of these pairs of factors also add to make 20? Well, that's going to be 2 and 18. So I can say that 18 times 2 equals 36, and 18 add 2 equals 20. So now let's rewrite this original expression using 18x and 2x to make 20x. So that would be 3x squared plus 18x plus 2x plus 12. Now again, I'm going to factorise these first two terms and factorise the third and fourth term. Factorising these first two terms, I can see I can take a 3 out of both of those terms, and an x. So I'm going to take out 3x, and then in my brackets, I'm going to have an x plus 6. Now let's factorise the third and fourth terms. I see I can take a 2 out of both. And then to go from 2 to 2x, I'm multiplying by x. From 2 to 12, I multiply by 6. And I see again, I get these matching brackets here, x plus 6 and x plus 6. So I can factorise this whole expression here, taking out the x plus 6, and that leaves me with 3x plus 2, and then my second bracket, x plus 6. So my final answer when I factorise this expression is 3x plus 2, x plus 6. Let's look at one last example where we're starting with 5x squared plus 23x plus 12. So again, we need to start off by multiplying together our coefficient of x squared by our number on the end. 5 times 12 gives us 60. We're then looking for a pair of numbers that multiply together to make 60, but also add together to make 23. So thinking about our factors of 60, lots of pairs of factors of 60 that we can find. We could have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, or 6 and 10. But only one of these pairs also adds to make 23, and that pair of factors is 3 and 20. So I can write this saying that 20 times 3 equals 60, and 20 add 3 equals 23. I'm then going to rewrite this original expression using 20x and 3x. So 5x squared plus 20x plus 3x plus 12. And then again, factorising my first two terms and factorising my third and fourth term. For my first two terms, I see I can take a 5 out of both and an x, so 5x. Then in my brackets, I'm going to have an x plus 4. Then factorising my third and fourth terms, I see I can take a 3 out of both. And again, in my brackets, I get x plus 4. We see that these two brackets match each other. So now we've got these matching brackets, I can factorise that out, and I get my double brackets of 5x plus 3, x plus 4. So my final answer when I factorise this expression is 5x plus 3, x plus 4.